What would happen if the moon didn't exist? What if Earth rotates in the opposite direction? Hi, I'm Neil deGrasse, and today I'm going to tell you if 100 what if space fact. Please subscribe and let's get started. Number 1, what if Earth spun twice as fast? Days would last 12 hours because the planet completes a turn in half the time. That scrambles body clocks in people, animals, and plants. Faster spin boosts centrifugal force, the outward push, which piles ocean water toward the equator, flooding low, flat regions like parts of the Amazon basin and northern Australia. That outward push partly cancels gravity at the equator, so you'd weigh a bit less there, roughly 1 to 2%. Number 2, what would happen if the Earth suddenly stopped spinning? Everything on it would keep moving at its current speed because of inertia, so air and oceans would rush ahead, causing hurricane-force winds and mega tsunamis. That violent shift would stress the crust, triggering earthquakes and ground deformation. Stopping the spin would disrupt the geodynamo in Earth's core that powers our magnetic field, letting in more solar and cosmic radiation. With no rotation, one side would face the sun and the other darkness for long stretches, driving extreme heat-cold weather. Number 3, what would happen if the Earth had no moon? The moon is like Earth's helper hand. Without it, Earth would wobble like a top, so seasons would get weird, too hot some years, too cold others, because the moon's pull helps keep Earth steady. Ocean waves would be much smaller because the moon's gravity lifts the water. With tiny tides, the sea wouldn't mix as well, so many beach animals would struggle. Earth's spin could change a bit, making bedtimes for plants and animals confusing because they follow light and dark. And nights would be much darker, so animals that use moonlight to see or travel would have a hard time. Number 4, what would happen if the Earth had 2 moons? Imagine 2 big night lights pulling on our oceans like magnets. This makes bigger and weirder waves because each moon tugs at different times. Nights would be brighter since 2 moons shine. We'd see more eclipses, like moons playing peekaboo with the sun. Number 5, what would happen if the Earth's axis were perpendicular to the sun? If the Earth's axis were perpendicular to the plane of its orbit around the sun, the planet would experience no seasons. The current inclination of approximately 23.5 degrees is what causes the different latitudes to receive more or less sunlight during the year, generating seasonal variations. With a perpendicular axis, the distribution of sunlight would be constant throughout the year, resulting in days and nights of equal length at all latitudes. This would affect climates and ecosystems, as the equatorial regions would receive direct light throughout the year, while the poles would remain in perpetual darkness. Number 6, what would happen if the Earth's axis was tilted 45 degrees? If the Earth's axis were tilted 45 degrees, the seasons would be much more extreme. During the solstices, a quarter of the planet would be left in complete darkness or continuous light, severely affecting ecosystems and human life. Regions outside the tropics would experience long periods of 24-hour days and nights, with temperatures ranging from extreme heat to polar cold. This would reduce the habitable zone and put biodiversity at risk, as species would have to adapt to extreme temperature changes. Number 7, what would happen if the Earth's magnetic field disappeared? The Earth would be exposed to cosmic and solar radiation without protection. This could damage the atmosphere, weakening the ozone layer and increasing exposure to dangerous radiation, which would increase the risk of cancer and mutations in living beings. In addition, satellites and power grids would be vulnerable to interference and damage caused by solar particles. The auroras would disappear, and the climate may have become more unstable due to the alteration of the atmosphere. Although life could adapt over time, the disappearance of the magnetic field would make Earth much less habitable. What if you fell into a black hole? As you drop toward a black hole, the gravity on the side of you that's nearer is stronger than on the side that's farther away. Since your feet are closer than your head, your feet are tugged harder. That uneven pull, called a tidal force, stretches you lengthwise and compresses you sideways. Scientists nickname this spaghettification because you'd be drawn out like a long, thin noodle. That's the key idea. Stronger pull on the near side, weaker on the far side, leading to stretch and squeeze. Number 9, what if the Earth were 20% larger? A bigger Earth has more stuff, so its gravity pulls harder. That's why you'd feel heavier and jump lower. The thicker air would be like wearing an extra blanket around the planet, making winds and rain stronger in some places. Trees, animals, and people would need to adapt. Because moving, flying, and even breathing could feel a bit harder. Some storms could grow stronger since there's more air and water to swirl around. Number 10. What would happen if Earth were the size of Mars? A smaller Earth has weaker gravity, so it can't hold on to air and water as well because the pull is softer. That means the atmosphere gets thinner, letting heat escape, so the world turns colder and drier, like Mars. With less air and water, clouds, rain, and oceans shrink, so plants and animals would struggle to live. Creatures would likely be smaller and simpler because growing big is harder when gravity and resources are low. In short, smaller planet, weaker pull, thinner air, colder, drier life. Number 11. What would happen if Earth's gravity doubled? If Earth's gravity doubled, everything would weigh twice as much, making it much harder to move, lift objects, or even stand upright. Our bone and muscle structure would be under constant stress, which would increase the risk of fractures, fatigue, and circulation problems. Plants and trees could collapse under their own weight, and large animals would have severe difficulties surviving. Number 12. What if Earth were tidally locked to the sun? One side is forever day and gets very hot. The other side is forever night and gets icy cold. In between, there's a twilight ring with gentle light. This could be the best place to live. Hot air rushes to the cold side and cold air flows back, making huge, steady winds and big storms. Oceans and air carry heat around, so some dark places get a little warmer. Plants near the day side grow under never-ending sunlight. The night side needs lights or heat to live. The sun stays fixed in one spot in the sky. Clocks and days would use weather cycles, not sunrise. Number 13. What if Jupiter's Great Red Spot collapsed? The Great Red Spot is a giant, long-lived storm. If it faded, the wind belts around it would change shape. New jet streams might slide into its place, making fresh swirls and smaller storms. Jupiter might shine a little differently since clouds reflect sunlight and trap heat in new ways. We'd watch lightning pop up in new spots and see colors shift as gases mix. Over time, another big storm could grow. Jupiter's atmosphere loves to make whirling spots. Number 14. What if the atmosphere had more oxygen than it does today? Oxygen is the helper gas we breathe, so more oxygen means breathing feels easier because there's more of the helper. Animals, and even bugs, could grow bigger and stronger because their bodies get energy from oxygen. Fires would start and spread faster because flames eat oxygen to keep burning. Some animals might run longer or heal quicker because their muscles get more oxygen. But there would be more wildfires and faster plant and germ growth because extra oxygen speeds up burning and life processes, changing how forests and lakes work. Number 15. What if the moon orbited backward or retrograde? The moon would move the other way across the sky, so the times for high and low tides would change. Some days the sea would splash higher, other days lower, while the new pattern settles. The moon and sun would line up differently. So eclipses would happen at new times and in new places. Over long times, Earth's spin and the moon's distance would shift a little in a new dance. Number 16, what would happen if the sun were 10% closer? Getting closer to a campfire feels hotter. Earth would feel hotter too because the sun's light is stronger when you're closer. Ice at the poles would melt more because heat makes ice turn into water. Raising the seas, many places would get drier and hotter because extra heat dries soil and plants faster. We'd see more big storms and fires because warm oceans power storms and dry forests burn easier. Animals and plants would struggle to stay cool and find water. Even our year would be shorter because a closer path around the sun means a quicker trip. Number 17. What would happen if the sun were 10% farther away? Being farther from a campfire feels colder. Earth would be colder because the sun's warmth is weaker. More cold means more ice grows and seas can drop because less heat melts less ice. Plants get less sunlight. So photosynthesis slows, making less food and oxygen for life. Farms would have shorter, colder growing seasons because crops need warmth and light. Our year would be longer because a bigger orbit takes more time to go around the sun. Number 18. What if the Earth had rings like Saturn? Rings are like a wide, flat, dusty hula hoop around Earth. They would block a little sunlight, especially near the poles, so it gets a bit cooler. Tiny bits from the rings could fall like sparkly dust or shooting stars, changing the air a little, so weird weather might happen because the air and sunlight are different. Would we see the rings? Yes. They'd look like bright bands across the sky, biggest near the equator, like a giant arch, and thinner near the poles because of how we're tilted. At night, they'd shine by reflecting sunlight. More little space pebbles could bump into us, so we'd get more meteors because the rings are made of countless tiny pieces. Number 19. What if Saturn lost its rings tomorrow? Saturn's rings are made of ice and tiny rocks. If they vanished, Saturn would look like a plain gold ball in the sky. For Earth, almost nothing changes. Our days and weather stay the same. Near Saturn, the ring bits would fall like dusty snow into the planet, ring rain. That dust could darken or brighten parts of Saturn's clouds since it changes how sunlight is reflected. Saturn might look a little less shiny, and its colors could shift in some bands. Number 20. What if the Earth didn't have an iron core? The magnetic field would disappear, leaving the Earth exposed to cosmic radiation. Earth's iron core is like a spinning battery that makes a magnetic shield. Without it, the shield vanishes, so space wind from the sun can hit us harder because nothing blocks it. That wind can steal our air and let dangerous rays reach the ground. Inside Earth would be cooler and quieter, so fewer volcanoes and quakes because hot moving insides power those. Number 21, what if a 300-meter city-killer asteroid hit? It's like a mountain-sized rock falling very fast. So it hits with huge energy, a big flash, boom, and shockwave. Near the hit, buildings can fall, windows shatter, and a crater forms as rock and dirt fly up. If it lands in the ocean, big waves and tsunamis race to nearby coasts. Farther away, people feel a strong wind and hear a loud rumble. Skies may turn dusty for a while. It hurts a region, not the whole world, not like dinosaur killer size. Number 22, what if Earth didn't have oceans? The absence of liquid water would eliminate the hydrological cycle, preventing the formation of clouds and precipitation, turning the planet into an arid desert. In addition, without oceans, the atmosphere would lose its main thermal regulator, leading to extreme temperatures and an unstable climate. The lack of water would also eliminate the main source of oxygen, essential for the respiration of most species. Remember, the oceans produce between 50 and 85% of the oxygen we breathe, thanks mainly to phytoplankton. Number 23, what if snowball Earth conditions tried to return? Imagine ice spreading from the poles until it covers almost the whole planet. Oceans get a thick ice lid and even beaches turn snowy. Ice is like a big mirror, so it reflects sunlight, making Earth even colder, so more ice grows, like a freezer turning up. Winds carry dust over the bright ice, skies look pale, and storms have less rain to drop. Over a long time, volcanoes add carbon dioxide to the air. That gas traps heat, the mirror ice melts, and the planet slowly warms back up. Number 24, what if Earth had a dense sodium tail like Mercury's? Imagine Earth dragging a golden, comet-like fan that points away from the sun, a super thin glow far above the air. It would shine a soft yellow at night like street lamp color, a little brighter at sunset and sunrise. Cameras and telescopes would see a huge sweeping tail. With your eyes, it looks faint and gentle. Tiny hits from sunlight and space dust knock sodium from the high sky, so the tail grows and shrinks with space weather. Aurora storms could make it wiggle, giving extra pretty skies. People and animals stay safe. The sodium is way up high, not in the air we breathe. Astronomers use special filters so the yellow glow doesn't hide stars and galaxies. Number 25, what would happen if the poles melted completely? The North and South Pole ice would turn into water, so the oceans get higher because melted ice adds more water. Higher seas would flood beaches and cities because water spreads out over low land. Cold, fresh meltwater would change ocean rivers, so places could get hotter or colder because currents move heat. People would have to adapt, build safely, move to higher ground, and use smarter ways to live with water. Number 26. What if Earth had two equal mass moons in a stable dance? Picture two bright moons taking turns in the sky. Their gravity tugs the oceans, making tide patterns that beat, some days extra high when both line up, gentler when they don't. We'd get more eclipses. Sometimes one moon hides the sun, sometimes the other, and sometimes both in the same year. Nights grow brighter, with double moonlight and two shadows from two night lights. Earth's spin would slow a tiny bit faster over long times. Two moons pull more, so days get a little longer very slowly. Number 27, what if the atmosphere was methane-like on Titan? Methane is a gas that isn't for breathing, so people and animals would suffocate because our bodies need oxygen. It makes a thick, dirty orange fog that blocks sunlight. Because tiny soot-like bits float in the air, with less sunlight, plants can't make food because photosynthesis needs light. Methane also traps heat like a big blanket, so the world could overheat because more heat stays in. It can catch fire easily, so sparks could cause dangerous flames because methane burns fast. Rain and rivers could be liquid methane, not water, because in this air, methane can condense. We'd need spacesuits and lights to live because there's no oxygen and days would be dim. Number 28, what would happen if the Earth had an extreme elliptical orbit? Sometimes we'd be much closer to the sun and sometimes much farther because an oval orbit changes our distance a lot. Closer means extra heat and brighter days. Farther means colder dot seasons would turn more extreme. The hot times get hotter and the cold times get colder. Some seasons could feel longer or shorter because Earth moves faster when close and slower when far. Winds, rains, and storms would shift because oceans and air warm and cool unevenly. Number 29, what if the moon were made mostly of ice? The moon would look extra bright and snowy, shining like a big ice lamp at night. Sun-warmed cracks could spray icy geysers, shooting glittery mist into space. Falling ice bits might make thin rings around Earth for a while, pretty bands in the sky. Astronaut boots would crunch on frosty ground, and holes from impacts would look clean and white. Robots could melt ice for water and air, turning moon camps into easier homes. Number 30. What if Saturn gained a new big ring? Saturn would look extra bright and shiny. With a thicker glow around it, nights near Saturn would feel a bit brighter. The new ring would cast wide shadows on Saturn's clouds, making cool, dark bands that change how clouds warm and move. Those shadow stripes could shift winds and make new storm lanes. Like sunglasses for parts of the planet, bits from the ring might snow down into Saturn's air, changing its colors a little. Number 31. What if Mars' moons merged into one larger moon? Mars would have one brighter nightlight in the sky. A heavier moon pulls harder, so tides get bigger, not ocean waves. Mars has little water, but slow ground and air tides that make the thin air and dust move more. Dust would lift and storm paths change. So some places get more dusty days and others less. We'd see longer eclipses when the big moon passes in front of the sun, and nights would be brighter under its glow. The new moon and Mars could settle into a steadier dance with gentler quakes from the extra stretch and squeeze. Number 32. What if the sky was green instead of blue? The sky looks blue today because tiny air bits bounce blue light the most. If they bounce green more, the sky would look green instead. The sun would still shine, but the world would feel like it had a soft green tint. Plants might grow a little differently because they use light colors to make food. But most would adapt over time. Sunrises and sunsets might look yellow, green, or teal because the colors the air lets through would shift. The weather and climate wouldn't change much, just the color of the light we see. Number 33. What if gravity repelled rather than attracted? Gravity is the hug that pulls things together. If it pushed instead, everything would fly apart because nothing would want to stay close. Clouds of gas wouldn't squeeze to make stars because the push would spread them out. No stars means no sunshine and no heat for worlds. Without stars, we don't get heavy elements like the stuff in rocks, water, and remember, those are made inside stars. No stars also means no planets and no galaxies because there's nothing to hold matter together. So a pushy gravity makes a universe that's just lonely dust, drifting farther and farther away. Number 34, what if Earth's core were smaller? Deep inside, a smaller hot metal core makes a weaker magnetic shield, so more space rays and solar storms reach us over very long times. The top of our air could be nibbled away a little by the solar wind, so we'd guard tech and astronauts extra well. With a smaller core, Earth's inside cools faster, so volcanoes and quakes may slowly calm down. And new mountains grow more slowly. People stay safe with better shields, smarter power grids, and space weather alerts to know when the sun gets feisty. Number 35, what if Jupiter lost half its mass? Jupiter is like the solar system's big traffic cop that pulls many comets and asteroids away. With half the mass, its gravity gets weaker, so more space rocks slip past. Over time, extra meteors and comets could wander toward the inner planets, giving more shooting stars and a slightly higher chance of big impacts. Jupiter's own moons and rings would settle into new orbits, and some small moons might drift away. The planet would shrink a bit. Its colorful storms could change, and its magnetic bubble might get smaller, so fewer super-strong auroras there. Number 36. What if the moon moved away from Earth at a much faster rate than it actually does? The moon is like Earth's dance partner. If it moves far away quickly, its pull gets weaker, so tides shrink and beaches change their daily splash. Earth's spin slows over time, so days get a little longer, like adding tiny extra seconds to each day. Eclipses become rarer and smaller since a farther moon looks tinier in the sky. Our seasons could get wobblier in the far future since a distant moon steadies Earth less. Months slowly stretch as the moon takes longer to loop around us. Number 37. What if the Earth's core was completely solid? Imagine Earth like a chocolate egg with nothing inside. Gravity squeezes the shell inward so the walls would cave in. Without a heavy, hot metal core spinning, the magnetic shield would fade, letting more space rays reach the sky. The ground could sag and crack, making sinkholes and big collapses, so towns would be risky. With the inner engine gone, plate tectonics and volcanoes would mostly stop. Some life could still live on the surface, yet everyday life would feel shaky and unsafe. Number 38. What would happen if Earth had an atmosphere like Venus's? Imagine a super thick blanket of air made mostly of carbon dioxide. Heat gets trapped and the ground turns oven hot, over 460 Celsius degrees. The air presses 90 times harder than on Earth, a squeeze like being deep underwater. People and animals couldn't live. No oceans or lakes. Water boils away or vanishes into the air. Clouds fill the sky with acid droplets, stinging and tearing at anything uncovered. Rocks near the surface could glow hot, metals like lead melt. The sun looks like a fuzzy orange light. The sky stays thick and hazy. Number 39. What if faster than light travel were possible? Spaceships could zip to other stars in days, turning faraway worlds into places we can visit and explore. Clocks and calendars might act funny on super-fast trips. Time could feel out of order for travelers and people at home. We'd need super strong shields and smart navigation, since tiny space dust hits like cannonballs at such speeds. New maps of the galaxy would grow fast. More planets, new skies, strange moons to study. Number 40. What would happen if Earth had the reddish color of Mars? Earth wears a red coat, so land and dust look rusty orange everywhere. Sunlight on red ground gets soaked up a bit more, making some days slightly warmer. Skies and sunsets shine deeper red, and snow or oceans can look a little pink. Plants might change leaf colors or timing to use the new light. Number 41. What would happen if the planet had the density of Saturn? A fluffy, low-density Earth would be much lighter, surface gravity tiny, like springy moon steps. With a weak pull, air slips upward and leaks to space, so the sky turns thin. Oceans shrink into shallow seas or icy patches as water drifts away as vapor. Weather flips, gentle breezes in some places, sudden dust gusts in others, storms less anchored. Fish, trees, and animals face new rules, little air to breathe, water levels changing, habitats fading. People wobble and tire differently. Bones and muscles lose strength in super low gravity. Number 42. What if you had a leaky spacesuit in vacuum? A spacesuit is your tiny house of air. A leak lets the air escape, so there's nothing to breathe. In vacuum, there's no air pressure, so your body's air puffs out, and you can faint in seconds. Water on your tongue and eyes would boil into bubbles, not from heat, but from the missing pressure. You wouldn't explode, but you'd get very cold and very sunburny. Space has no air to warm or shade you. Astronauts train to find leaks fast and seal them with patches or get back to the ship with a good suit that doesn't leak. You stay safe, warm, and able to breathe while you float among the stars. Number 43. What if the sun's core suddenly turned off its fusion? The sun is like a giant oven. Its middle or core makes the heat and light. If the oven turned off, we wouldn't notice right away. Sunlight already on the way still arrives for 8 minutes. The sun outside stays hot for a long time, so it would fade slowly, not go dark like a lamp. Over many years, it would get dimmer and cooler, and Earth would start to freeze. Plants would make less food from light, animals would struggle, and people would need warm shelters and lights. Number 44. What would happen if the magnetic poles were at the equator? Compasses would point toward the equator, not north. Birds and turtles get mixed up at first, then learn new routes. Auroras would glow over tropical beaches at night. Power and radios might act funny in the middle of the world. Earth's magnetic shield still works, just in a new shape. Weather stays almost the same. Animals, plants, and people adapt step by step. Number 45. What if the other 7 planets were placed between Earth and the Moon? The gap to the Moon is so big you could line up all those planets side by side and still have space left. They'd look huge in the sky. Jupiter and Saturn like giant colorful balls. Nights would be bright like dawn. Their strong gravity would tug our oceans into megatides, flooding coasts again and again. The moon's path would go wild, maybe breaking apart or flying away. Earth's ground could shake more as the crust stretches and squeezes. Soon the whole setup would fall apart, with planets pulling each other until everything moved away or crashed. Number 46. What if dark energy suddenly changed strength? Think of space like stretchy dough, and dark energy is the stretch knob. If the knob turns up, space stretches faster, galaxies race away. And the night sky looks emptier as their light fades. Turn it way up, and the stretch could get so strong it pulls apart galaxies, stars, one day even tiny things, a scary big rip. If the knob turns down, the stretch slows, gravity clumps stuff more, and the sky could look busier over time. Turn it way down or off, and the universe might stop stretching. After a very long time, it could even fall back in. A big crunch. Nothing changes for us right away. These are huge, slow space changes, but over ages, the universe's look and future would be very different. Number 47, what if Earth orbited inside the asteroid belt? The sky would have more rock neighbors, so we'd see extra shooting stars and sometimes bright rock dots through telescopes. Space is still mostly empty, yet Earth would get hit more often by small space rocks. So we'd build better shields and warning systems. Big hits could kick dust into the air, making some days dimmer and cooler until the dust falls. Oceans and ground might feel tiny shakes from close flybys, and pilots' satellites would follow safer space lanes. Number 48. What if Earth passed through a dense interstellar cloud? Space has wispy clouds of gas and dust. A dense one makes our sky dustier and sunlight a bit dimmer. The sun's bubble that shields us, the heliosphere, gets squeezed, so more space particles reach near Earth, bigger auroras and some radio glitches. Tiny dust grains drift into our air, letting more streaking meteors and silvery night clouds appear. Days may feel a little cooler and hazier since dust blocks and scatters light. Number 49. What if you shot a gun in space? A gun would still work in space because bullets contain their own oxidizer for the gunpowder. Firing a gun in space would be silent, but would cause the shooter to be pushed backward due to recoil. Newton's third law. The bullet would travel in a straight line until gravity from a celestial body pulls it off course, and smoke and debris would float away in all directions without rising. Number 50. What if the Milky Way-Andromeda merger happened much sooner in our skies? At first, you'd see a tiny fuzzy patch grow every year, then big curvy star arms filling the night like two glowing whirlpools meeting. When the galaxies hug, gas and dust get squeezed, so lots of new baby stars turn on, sky fireworks. Our sun and planets almost never hit other stars. Space is mostly empty, so we keep orbiting safely. Gentle gravity tugs could shake loose extra comets and meteors, giving more shooting star nights. The whole star city slowly becomes one bigger galaxy, and our solar system drifts to a new address inside it. Light in the sky gets brighter on some nights, and telescopes see amazing shapes and lanes of dust. This show still takes many human lifetimes, so people would watch it change like a very slow movie. Number 51. What if Mars had never lost its magnetic field? A magnetic shield is like a big umbrella that protects a planet's air. With the shield on, the sun's space wind can't blow Mars's air away so easily. So Mars keeps a thicker atmosphere. Thicker air holds more heat and water, so rivers, lakes, and maybe small seas could last much longer. Plants and animals would have a better chance since there's more air to breathe and water to use. Days would still be cold, but not as freezing as today. Dust storms might be softer, skies a bit bluer, and explorers could use simpler suits with more help from the air. Number 52. What if the sun were replaced by a much faster rotating star? A super spinning sun squishes a little flatter in the middle like a pizza twirling, so its equator looks wider. Spinning stirs up a stronger magnet inside the star, making bigger sunstorms and extrasolar wind. Earth would get more space weather, brighter auroras, and sometimes radio or GPS and power lines act funny. Fast spin can make the sun's poles look brighter and the middle a bit dimmer, light spreads unevenly. Planets closer to the sun could lose air faster to the stronger wind. Days on Earth stay the same length, yet some days the sky shows extra sunspots and lively aurora nights. Number 53, what if Venus lost most of its atmosphere? Venus wears a giant hot blanket of air. If most of that blanket went away, the planet would cool a lot, no longer melt metal hot, but still super toasty. The sky would clear with fewer acid clouds so we could see more mountains, plains, and big volcanoes. The air would turn very thin, so winds near the ground get gentler and sound carries poorly. No oceans would appear. Venus stayed dry long ago, so it would still look like a hot, rocky desert. Days remain very, very long on Venus, so the sun would creep slowly across the sky. With less air, more space rocks could reach the ground, and sun-burning rays would be stronger, so robots and people need tough suits. Number 54, what if Earth lost plate tectonics? The ground becomes one big hard lid, so no more sliding plates, fewer quakes, and fewer new mountains. Volcanoes fade, Earth loses its long-term thermostat. The air's carbon dioxide no longer gets recycled well by rising rocks and rain. Over long times, the world can drift to too cold or too hot. Old mountains wear down, but new ones don't grow, so continents get flatter. Deep inside, heat builds up under the lid. Rare, giant eruptions could still burst through. Number 55. What would happen if the Earth had a fluorescent atmosphere? If Earth's atmosphere were fluorescent, gases or particles absorbed IUV light, radiation, and re-emitted it as visible light. Dramatic visual effects would be seen. The sky could glow at night or dawn even without visible moons or stars. Constant luminosity could affect the sleep cycles of living beings, alter the biological rhythms and natural navigation of some animals. In addition, increased light emission could raise the temperature in certain atmospheric layers and modify weather patterns. Number 56. What would happen if the Earth had a second layer of ozone? Ultraviolet radiation would be even more filtered, protecting life. Photosynthesis could be disrupted by less radiation. Ecosystems would adapt to less direct sunlight. Weather events may change slightly. Human life would be more protected from solar radiation. Number 57. What if there really is a Planet 9 way out beyond Neptune? Picture the solar system as marbles circling a lamp. Far away, a big, slow marble, the Planet 9, gives tiny tugs to the others. Today, those tugs are gentle, so nothing big happens near us, just small wobbles and far-out ice rocks. In the very distant future, the sun puffs up and loses weight, a red giant, so its pull acts like a looser rubber band. With the band looser, Planet 9's extra gravity nudges matter more, and outer planets can shuffle their paths. Some could drift outwards, swap places, or even get kicked away, like marbles bumping when the circle slows. This would take many, many lifetimes. Number 58. What if Earth had a thick hydrogen atmosphere like a mini Neptune? Hydrogen is a very light gas. A huge, puffy blanket of it would press hard on the ground, so the air pressure feels crushing. Sunlight gets trapped in the thick air, making a strong greenhouse, so the world turns warm and hazy. The sky looks milky with high clouds. The sun seems dimmer and more yellow through the haze. Mountains and oceans feel strange. Water can get hot and squish deep below the heavy air. Birds and planes wouldn't fly well in such different air, so people might float in big balloons filled with helium. Satellites and radios need extra protection. Number 59. What if Earth's core cooled enough to stop the geodynamo? Earth has an invisible shield made by hot, moving metal deep inside. If the engine stopped, the shield would fade, so more space stuff, charged particles could reach us. Number 60. What if Venus cooled to Earth-like temperatures? Venus now wears a super hot, heavy blanket of air. If it cooled a lot, that blanket would thin, so heat escapes and the ground gets comfy. The thick acid clouds would fade, showing mountains, valleys, and big volcano plains. Rock once too hot to touch would harden. And some places could hold puddles, lakes, or shallow seas if water returned. Skies might turn pale yellow or blue with gentler winds and shorter days, nights still very long. Number 61. What if the sun suddenly lost 1% of its mass? The sun's pull gets a tiny bit weaker, so Earth slides to a slightly bigger circle around it. Our year becomes a little longer since the trip around the sun takes more time. We get a bit less sunlight, so the planet leans cooler, longer winters, gentler summers in some places. Number 62. What if Earth had a persistent, thin, oxygen-poor haze like early Earth? The sky would look amber, like sunset, since tiny haze bits scatter blue light away. There would be less oxygen to breathe, so animals and people would need helped air in many places. The haze would filter sunlight, letting in different colors and some extra IUV, so hats and shade matter more. Plants might use new light colors to make food, so leaves and forests could look different from today. Days feel a bit dimmer, and faraway mountains look fuzzy through the mist. Number 63. What if Venus lost most of its carbon dioxide? Venus wears a giant hot blanket made of carbon dioxide. If most of it went away, the planet would cool a lot. Thick acid clouds would thin, and we could see mountains, valleys, and hidden continents. Rocks that were oven hot would harden, and some low places might keep puddles or lakes if water returned. Skies could turn paler, winds calm a bit, and days would still be very long there. Number 64, what if the sun had a long, quiet minimum? Fewer sunspots and solar storms means the sky has smaller auroras, the night lights fade, the very top of our air gets cooler and thinner, so satellites stay up longer and don't slow down as fast. With fewer solar tantrums, radios, GPS, and power have fewer glitches. Down on Earth, weather feels almost normal, maybe a little cooler in some places. Number 65, what would happen if the Earth had a moon with oceans? Imagine the moon with big blue seas. Earth and moon would pull on each other's water, so tides on Earth get bigger and the moon would have tiny moon tides too. The moon would stretch and squish a little as it orbits, warming inside. That warmth could make geysers or small volcanoes on the moon. Some beaches on Earth would see new tide patterns and ocean currents could shift, changing where warm and cold water go. At night, the moon could look brighter and shinier as its oceans reflect sunlight like a mirror. Over very long times, the tug of war could make the moon drift a bit farther away step by step. Number 66. What if the moon's surface got much darker? Nights would be dimmer since a dark moon reflects less sunlight, fewer bright moon nights for camping or reading shadows. Tides stay the same, the moon's pull doesn't change. Only the shine changes. On the moon, darker ground soaks up more sun, making hotter days. Nights stay freezing as always. Number 67. What if Mercury had a big moon? Mercury and its moon would tug on each other. So the little planet gets gentle stretch and squeeze warming inside, like kneading dough. That extra warmth could wake up old volcano spots and make the ground crack in places. The moon's pull would slow and change Mercury's spin over time. So a Mercury day could shift bit by bit. Near the sun in our sky, they'd make wild eclipses. Sometimes the moon hides the sun from Mercury. Sometimes Mercury hides the sun from the moon. From Earth, it would be hard to see since Mercury stays close to the sun's glare. Best views at sunrise or sunset with telescopes. Number 68. What if Earth orbited through a comet's tail every year? A comet has a long, shiny tail. When Earth passes through it, we get a yearly sky show with many shooting stars. Tiny dust bits hit the air and make silver streaks. High night clouds can glow brighter. Most dust never reaches the ground. The air burns it up. Planes and rockets use safe paths. Satellites get a light dust scrub, so engineers add shields and cleanup orbits. Number 69, what if the sun's 11-year cycle paused at a deep minimum for 30 years? The sun's space weather turns calm, so we get fewer sunspots and smaller auroras. With less sunlight spice, high-energy rays, Earth's top air cools and shrinks, so it's thinner way up high. Thinner top air means satellites don't slow down as much. They stay in orbit longer before falling. Our magnetic bubble blocks fewer cosmic rays, so more of these tiny space bullets reach near Earth. Pilots and astronauts need extra care. Down here, temperatures might get just a tiny bit cooler. But everyday weather still feels mostly normal. Number 70. What would happen if the planet rotated in the opposite direction? The sun would rise in the west and set in the east, since the sky's motion comes from how Earth turns. Big winds and ocean rivers would flip direction as Earth's spin guides their paths. Wet coasts could turn drier, and dry coasts wetter, with rain belts and deserts shifting. Storms like hurricanes would twist the other way. Because spinning air follows Earth's turn, birds, sea animals, and people would learn new routes and seasons' rhythms as patterns change. Your day would still be about 24 hours. It's the speed, not the direction. That sets day length. Number 71. What if Uranus hadn't been knocked on its side? Uranus now lies on its side like a sleepy ball. If it stood straight up, sunlight would spread more evenly all year. Seasons would be mild. Not super long days or super long nights at the poles. Its rings and moons would circle like a neat hula hoop around its belly, not like a wheel standing on edge. Polar places would get some normal daylight each day, so the poles wouldn't freeze so extremely. Space probes and telescopes would see a planet that looks less odd, with steadier light and weather. Number 72. What if Earth were closer to Jupiter? Jupiter is super huge. So its gravity tugs hard, Earth's path could wobble, and tides would rise higher. Oceans and the ground feel extra stretch and squeeze, making more quakes, and some volcanoes wake up. Big winds and rain patterns could shift. So some places get wetter and others drier. Jupiter's radiation belts add extra space sparkles that can bother satellites in high skies. Overall, Earth turns shakier and trickier for life, like living next to a very strong neighbor. Number 73, what if the sun fired a Carrington-class storm at modern Earth? Sometimes the sun has a huge tantrum and throws lots of charged particles at Earth, like a giant space snowstorm. Earth's magnetic shield catches most of it and turns it into mega auroras that can glow far from the poles. Up high, the storm can make satellites and GPS get confused, so maps and phone signals may not work right. Airplanes may change routes, and astronauts wait in safe spots to avoid extra radiation. Number 74. What would happen if the Earth were in the Alpha Centauri system? We'd get light from different stars, sometimes one bright sun, sometimes two, so days could feel brighter or dimmer at times. The stars there have slightly different colors and warmth, so plants might change how they grow to use the new light. Our year could be longer or shorter since Earth would go around a new sun on a new path. Seasons and weather could shift with new rain and wind patterns as the heat from the star changes. Number 75. What if Jupiter tugged Earth into a wilder orbit? Earth would travel closer to the sun, some months extra hot and farther other months extra cold since the path turns oval. Summers could be super warm and winters extra chilly, so places switch between comfy and tough times. Oceans and air move heat around differently, making new wind and rain belts. Deserts and wet zones can shift. Some regions become nice and watery for part of the year, then dry or icy later. Habitats move with the seasons. Number 76. What if Earth formed inside a dense star cluster? Imagine our baby Earth growing up in a busy star neighborhood where bright, young stars live very close together. Those stars shine with strong light and winds, which can blow away air and water from tiny worlds, so keeping oceans is hard at first. Sometimes a nearby star swings past. It's gravity giving our solar system a little shake, nudging comets and rocks toward the inner planets. More flying rocks means extra meteors and impacts, so safe, calm times arrive later. Number 77. What would happen if the Earth had an atmosphere of pure nitrogen? Nitrogen is a quiet gas, so people and animals can't breathe. We need oxygen for our bodies to work. Fires wouldn't burn, and candles wouldn't stay lit, since flames need oxygen to keep going. Plants couldn't make food well, since they need carbon dioxide and light for photosynthesis. The air would miss an ozone shield made from oxygen, so sun-burning rays reach the ground more. Tiny helpers that turn nitrogen into food for plants would struggle, so soils turn poor. We'd need spacesuits and oxygen tanks to live, and farms would need sealed greenhouses with the right air. Number 78. What if Mercury had a thick atmosphere? Mercury is tiny and very close to the sun, so a thick air blanket would get super hot on the day side. Hot air would rush toward the cold night side, making huge non-stop winds that howl around the planet. The thick air would slow down how fast rocks heat and cool, so days feel less burning and nights less freezing. Some air would leak to space over time. Mercury's gravity is small, so we'd need shields to help it stay. Skies would glow bright near the sun and look dimmer on the night side, with powerful sandstorms sweeping the ground. Number 79. What if Mars had Earth-level oxygen but thin air? The air would have good oxygen to breathe, but it's too thin, so lungs still struggle and you'd need a pressure suit. Fires and candles would light easily. Oxygen helps flames, yet the thin air makes flames small and wiggly. Water would boil sooner and evaporate fast, so puddles and tea kettles behave funny in the low pressure. Sound is quieter and whispery. Running and jumping feel tiring even though Mars's gravity is lighter. People could live there with helmets and habitats, using the oxygen to breathe and the suits to keep the right pressure. Number 80. What if Earth's upper atmosphere doubled in water vapor? High up, water acts like a heat-trapping blanket, so the planet holds in more warmth. The ozone shield can get weaker when extra water makes special cleanup gases. So more sunburnt rays reach the ground. We'd see more thin, high clouds and brighter silver night clouds in summer skies. Some places could get stronger storms as extra heat and moisture power bigger clouds. Airplanes might meet bumpier air up high, and satellites feel small changes as the top air shifts. Number 81. What if Jupiter migrated to 1 AIIU and Earth had to share its orbit? A giant striped world would fill the sky, way bigger than the moon, making some days and nights glow brighter. Jupiter's huge pull would make megatides, so the sea would rise higher and fall lower along many coasts. Earth's path could wobble, so some years feel extra hot and others extra cold as our distance from the sun shifts a little. The moon's route might change, giving new eclipse days and different night skies. Number 82. What if Earth orbited a white dwarf at the perfect distance? A white dwarf is like a small hot ember star, so Earth must orbit very close to feel warm. Our year would be short. Daylight looks bright white blue, and nights show lots of sharp stars, so close to the star. Earth might lock one side to face it, one side day, the other night, with a comfy twilight ring in between. We'd need a strong air and magnet shield to handle extra bright light and space particles. White dwarfs cool slowly over a long time, so the star gets dimmer and we'd need more warmth someday. Number 83, what if our planet's core split into two mini-cores? Deep inside Earth's hot metal engine would become two engines, each spinning and heating in its own way. The magnetic shield could turn messy, with bumpy spots and weird compass directions, since two engines make a tangled magnet. Some places might get more quakes or new volcanoes. As heat and push from below arrive in lumpy patches, animals that follow Earth's magnet could get confused until they learn new routes. Auroras might glow in surprising places, not just near the poles, as the magnet wiggles around. Number 84. What if the poles were hot and the tropics cold? Imagine a flashlight shining strongest on the poles, and gently on the middle the heat map flips. Hot poles melt ice into oceans, while the tropics grow chilly with frost and snow. Big winds and ocean rivers reverse, sending warm water toward the poles and cold water to the middle. Rain belts move, places that were jungles can dry out, and icy coasts can turn rainy. Number 85, what if a nearby magnetar flare hit our magnetosphere for a day? A magnetar is a tiny star with a monster magnet. Its flare would smack Earth's magnetic bubble, squeezing it hard. The skies could glow with huge auroras even near the equator, as extra space energy pours in. Satellites, GPS, and radios might act funny, and power lines could feel surprise currents, so helpers might switch things off. Astronauts would hide in safer spots, and some airplanes would use different routes high up. Number 86, what if the sun's color shifted to deep orange for a century? Days would look warm and golden, since the sun shines redder light that our sky spreads differently. Sunsets glow extra peach and copper, and noon light feels softer, not so bluish. With less strong blue UV light, we'd wear hats and sunscreen a bit differently, and some animals change their day-night habits. Solar panels still work, but helpers might pick kinds that like redder sunshine. Seasons and day length stay the same. The sun's color changes the look of light, not Earth's path. Number 87, what if a super-Earth formed between Earth and Mars? Picture a big extra planet parked between us and Mars. Its strong gravity would tug on all the rocks nearby, grabbing many that would have built our Earth, so our world could be smaller or not form at all. The new planet could steal or trap moons, change where asteroids live, and make a different map of our solar system. If Earth still formed, we'd grow up in a crowded neighborhood with extra bright planet nights and new eclipse chances. Number 88, what if we lived inside a giant ring world around the sun? Picture a huge metal hula hoop circling the sun, so wide it could hold millions of Earths. We stand on the inside of the ring. Its fast spin makes a gentle pushdown that feels like gravity. The sun hangs in the same spot in the sky. Day and night come from giant shades sliding on and off. Air stays in with tall walls at the ring's edges. Farms, rivers, and cities stretch in a never-ending strip. Travel takes days and days in one direction. No around the world, only around the ring. Tiny space rocks need shields, cracks need repairs, and the spin must stay steady so the ground feels safe. Number 89. What would happen if the Earth had more than one core? Imagine Earth with two hot engines inside, each turning in its own way. Heat would rise in odd patches, so some places get extra warm underground and others cool. The magnetic shield could turn messy, compasses point different ways, auroras glow in strange places, plates might push and pull unevenly so we'd feel more quakes, and some new volcanoes, rocks deep below could twist and crack as the engines tug in different directions. People build stronger cities and better warning systems to stay safe. Number 90. What would happen if the Earth had no gravity on its surface? If the Earth lacked gravity on its surface, the effects would be catastrophic for life as we know it. The atmosphere and oceans would disappear as there would be no force to stop them, leaving the planet in a vacuum without air or water. The physical structures would disintegrate, as there would be no force to hold them together. Life on the surface would be unviable without gravity, as gravity is essential to maintaining the Earth's atmosphere, oceans, and structure. Number 91, what if a gamma ray burst pointed at Earth for a few minutes? A gamma ray burst is like a giant space flashlight that flashes super strong energy for a few minutes. That energy can tickle our air and wear down the ozone shield, so extra sun rays reach the ground for a while. Satellites and radios might act funny, and we could see big auroras in the sky. The side of Earth facing the burst gets the strongest zap, the other side is safer. Number 92, what if Venus had Earth's rotation rate? Venus now turns super slowly, making one day longer than a year. If it spun fast, days and nights would come quickly like on Earth. Quick turning stirs the thick air more, so big winds and storm bands spread heat around instead of letting one side bake. Fast spin helps make strong jet streams, moving clouds like giant rivers in the sky. Its shiny clouds could reflect more sunlight during the day, so the surface might get a little less extra heat. Even with better stirring, Venus keeps its heavy carbon dioxide blanket so it stays very hot overall. Number 93. What if Earth orbited a red dwarf star and faced frequent stellar flares? A red dwarf is a small, dim, reddish sun. So Earth would orbit closer to stay warm, and our year would be shorter. Daylight would look a bit red-orange, and plants might grow differently under the redder light. Sometimes the star has big tantrums. Flares that blast space with strong light and particles. We'd see huge auroras, and radios, GPS, and satellites could glitch during those blasts. Number 94, what if all the planets were the same distance from the Sun as Earth 1 AIU? All the planets would try to share the same track, like many cars on one narrow lane. Their gravity tugs on each other make them swerve, so paths cross and get messy. Soon there'd be near misses, then some bumps. Planets could collide, break, or get kicked out into space. Moons would get shaken loose, making extra rocks and bright meteor showers in our sky. On Earth, we'd see huge planets in the daytime, but the show wouldn't last. Too many tugs. After the chaos, only a few survivors might keep orbiting, the rest crash or fly away. Number 95. What if the asteroid belt coalesced into a planet? All those space rocks gather into a new middle planet between Mars and Jupiter. Its gravity tidies the neighborhood, fewer loose asteroids. So fewer space rock hits on Earth after a while. At first, leftover pieces crash together, making bright fireballs and helping the new world grow. The new planet gently tugs on Mars and Jupiter, so their paths shift a tiny bit over long times. Earth might feel small changes far in the future, but your days would mostly feel the same. Number 96. What if a nearby supernova went off close enough to glow in daytime? It would shine like a new daytime star. Since the blast makes huge light and energy, skies could show big auroras as space particles shake Earth's magnetic shield. Some energy can hurt the ozone layer, so extra sunlight might be more stingy on our skin and eyes. Satellites, radios, and power could glitch as the blast tickles our space tech. Number 97. What would happen if the Earth were completely flat? If the Earth were completely flat, gravity wouldn't work as we know it. Gravity would pull toward the middle of the flat sheet, so air and water pile up in the center and get thin near the edges. Oceans near the rim shrink, the center floods, and big winds race from edge to middle. No deep hot metal core means no strong magnetic shield, so more harsh space rays reach the sky. Weather turns wild, giant dust storms, strange rain belts, and sudden cold and heat, seasons, eclipses. And satellites stop matching what we see, since a flat world can't make those patterns well. Number 98. What if a rogue planet passed through our solar system and tugged on Earth's orbit? Imagine a big bowling ball rolling past a set of marbles. Its pull could make Earth's path wiggle a little, so our year and seasons change a tiny bit. If it came closer, the oceans could make bigger tides, and the ground might shake more from quakes since gravity is tugging harder. The moon could shift in its path, making nights look a bit different. Number 99. What if the moon crossed inside Earth's Roche limit and broke into a ring? The moon would cross a no-hug zone, the Roche limit, where Earth's pull stretches it apart, turning it into millions of icy, rocky pieces, a shiny ring around our planet. Nights would show a bright band across the sky. Sometimes it would glow, sometimes cast thin shadows at sunrise and sunset. With the moon's pieces closer, tides could grow much bigger, so coasts would change their daily rhythm, and some beaches might flood more often. Tiny bits would fall like shooting stars, and once in a while a larger chunk could reach the ground. So we'd need better meteor safety. Earth's spin would slow a little faster, so days get longer very slowly. Number 100, what would happen if Earth approached a nearby black hole? A black hole is like an invisible, super strong space whirlpool with an enormous pull. As we get close, the near side gets pulled harder than the far side, so Earth stretches like spaghetti and starts to tear. Air and oceans peel away first, rushing into a hot, glowing ring around the hole. Starlight bends into weird arcs and halos, so the sky looks warped and strange. Clocks near the hole tick slower, so time feels stretched compared to far away. Earth's path turns wild. It might get flung off or spiral inward. Radiation and heat near the hole grow extreme, so life can't survive. And that's all, my friends. What fact surprised you the most? Leave it in the comments and subscribe for more space fun facts.